Rapid threat model prototyping. Okay.
Go for it.
How's everyone doing? Wow, what a great audience. Huge groups of people. I know they're all going to come in later on, so I'm going to be happy about that. Okay, my name is GEOFFREY Hill. Yes, to Temantic. I founded this company back in 2015 with the express purpose of helping out in the problem of doing threat modeling. Now, but we're not going to talk about that today. What we're going to talk about is we're going to talk about a methodology which I've created which speeds up threat modeling called rapid threat model prototyping. It's a mouthful, so I might just refer to it as RTMP instead. So first of all, it's Creative Commons. You guys can go to GitHub, you can download the documents, you can do uploads, you can help me out, you can do whatever you want with it, you can fork it, you can everything like that you want to do. But it's open source. Who am I? How many people, I think a few people over here know who I am, but who am I? Well, I mean, I'm just a guy up here talking, but I have a few things that I can give you that give me a bit of background on this. First of all, in the 1990s, I spent a lot of time going around the world, programming on various projects and everything like that, and learning about how people program, how people screw up, how I screw up, that kind of thing right there. So I got a good idea of how projects go nuclear. In the early 2000s, I started with Microsoft, a small software firm. And about the same time was when they started doing threat modeling in earnest there, because Bill Gates got really pissed off that they kept on getting hacked. And I love this idea. Threat modeling, what was this? A way to find out things, a way to basically pen test or hack an application before you wrote any code. How cool is that? Well, carried on, and I spent 5 years, well, nearly 5 years at Visa in London, and I was the sole application security guy right there, which is kind of strange because Visa is a very big company, especially Visa in Europe. And I did a lot of this right here. I did a lot of work, and I started refining the technique that I now call RTMP. You know, so I'm not calling it rapid threat model prototyping because I'm going to run out of words pretty soon. So now I'm the founder of Temantic. You guys can see right there. So if you see that logo, that's about the last time you're going to see that logo. Off we go. All right, 3 points right here. By the way, I'm going through puberty. Sorry about this. I blame you guys right here for last night's dinner. Okay. So first of all, we're going to kind of go over for you guys, what is threat modeling? I mean, well, let's get a show of hands. Who all here knows what threat modeling is, does threat modeling? A good chunk of people. Great, great. So it's going to be pretty fast. Well, we're going to kind of go over the basics right here, because I want you guys to understand the basic fundamentals of threat modeling. After that, who all knows agile architecture? Oh, fewer people there. All right. We're going to talk about the concepts of agile architecture and how we can fit that in using threat modeling, because that's going to give us the final one right here, which is rapid threat model prototyping. Oh, and by the way, who all knows about software prototyping? Nobody? Guys, you do it all the time. It's called agile. All right. So, what should threat modeling do, right? Here's a big question. Well, it should talk about 3 things right here. So when you do threat modeling, you should be answering these questions right here. Secure by design. You should be looking at defense in depth. And your models and your designs should take a look at that and be able to defend themselves, especially in a microservices world. All right? The second thing is they should be secure, and they should fail to a more secure state. Sorry, a secure state. So if something fails, it should take the principle of identity into account. Everything inside the application should have identity. There should be no anonymous whatsoever. And then second of all, the principle of least privilege. Don't give it more privilege than it needs. And the last thing right here that we talk about, especially in the DevOps world, is it should be secure in deployment. And there are 2 concepts right there. The first point right here is know your endpoints. Know what communicates inside and outside. How do you think in 2000 that Microsoft got bitten so hard? It was an open port on an SQL server. How do you think that Sony got attacked in 2010? It was an SQL server. It was an open endpoint. The second thing the bad guys do is they look for communication protocols, and they basically exploit those communication protocols. If you know those 2 parts right there, you can communicate to any person who's in infrastructure, and you can do it well. Okay, so those 3 things right here, that's the first point right here about threat modeling. Threat modeling should answer. The second point the threat modeling should answer is it should understand, and you should be able to explain everything on that diagram via threat modeling. Upper left-hand corner, owners. Who are the owners? The owners are the stakeholders. They're your bosses. They're people who lose their voices. And they're anybody who you work with on the team, all the way up to the CEO. The owners, they know what the assets are, right? You should know what the assets are. You should understand what the assets are. In between, you have the most important parts of a threat model. You have vulnerabilities and threats. Vulnerabilities are actual issues. Threats are not fictitious, but they're potential issues. They all feed in. They should have a one-to-one relationship with the countermeasures. Your threat model should take care of that. In the lower left-hand corner, it's interesting about threat agents because threat agents are more or less relevant depending upon what industry you're in. I say more or less relevant because in the end, we're talking about threats. And a threat model is going to be measuring the threats, not the threat agents. But they should be important, especially if you work in government or if you work in other industries that deal with all sorts of nefarious characters. But in the end, right here, your threat model should take care of all this and should answer all these questions and fill this out. By the way, that came in, what, 2005? It's very old, but it's still quite relevant now. Okay, threat modeling should also answer the question of flaws versus bugs. Okay, folks? Because the threat model will talk about your design. Your design is all about flaws. Okay, the implementation issues are the bugs right here. If you answer that and you work out the flaws, it's a lot cheaper because the flaws get built in. Now think about this though. If you build in a flaw and you implement that perfectly, every implementation you have is going to have that flaw, and it's going to have dependencies based upon that flaw. It's going to cost a lot of money to fix that, isn't it? And a lot of time. That's why threat modeling is so good. Okay, you guys have seen this. This is Adam Shostak's little design right here. I love it. You know, it's like, okay, you start at the top right there, you model, you understand what the system is. How many people here have done threat models for groups where when they whiteboard out the solution, I've had this a number of times, they go, ooh, I've never seen it that way. But you've never drawn it out? Because a lot of times Agile teams don't do that anymore. They don't draw out their solutions. And I got to tell you, that makes me worried. If they don't know how their solutions are connected up or how they can visualize them, that's very dangerous indeed. But you want to model out your solution, and you want to look at your dependencies, which are external interactors with your solution depends upon, and you want to understand how your solution is built up in terms of trust. What areas do you have to trust more? What areas do you have to trust less? Once you finish with that, you start analyzing the threats. So we use a threat framework. Who all here uses Stride? Show of hands. Okay. Who all here uses OWASP Top 10? Okay. Who all here uses OpenSAM? Which you can do, but who all here does use OpenSAM just for generic reasons? A few hands. Okay. All right. BSIM? Fewer. We're getting fewer and fewer. Security frame? Crickets chirping? Okay, no problem. You can look it up. But anyways, what you do is you find a threat framework and you use that threat framework and you become consistent with it. You use it throughout your threat modeling activity. And you look for security control mismatches. Because ultimately, what is the goal of a threat model? Ultimately, it's not to find the threats, it's to find the controls, the mitigations. You want to, because we're in the business not of discovering threats unless you're an attacker. We're in the business of getting there and fixing the stuff before it gets put into code. Therefore, my opinion is our business is to find those security control mismatches and to get them put into the design. Then you go through and you analyze the mitigations, and you can do one of two different ways. You can either accept it, which, to be honest, a lot of our business managers do. Yeah, sure, we'll accept it. Or you can reduce whatever that issue is, which is what we want to do in this room right here. And you do that by looking at your security requirements or your security objectives or your security framework or whatever it is, and you look at that security framework and you say, okay, how am I going to go about reducing this? Now, you may have an in-house set of security requirements. You may use an OWASP set of security requirements. I don't care. Whatever fits for you and whatever fits for your teams, right? So finally, the last part right here is validating. Now, in a DevOps environment, this is where it becomes problematic because if you do this is a very waterfall-y thing right here. And you go about validating it, you do a static code review and testing. You don't want to get that done too late, do you? You want to get that done on time so that they can actually get that into the code. So I want to get a show of hands of people. Well, actually, I'm jumping ahead of myself, so let's go to the next one. How does traditional threat modeling fail us? Okay, so a show of hands of people is you start a threat model, team starts arguing, you kind of get finished with the threat model, but you don't get finished. You keep on working on it. The threat model kind of bleeds along, and you're already in sprint 2. Show of hands of when it's happened. Quite a few people, right? Kind of annoying, isn't it? Especially the fact that you're out there and you're trying to work it, and then you get busy because we're all busy people, and you can't update that threat model. Oh man, this starts getting really annoying. Okay, So too much time spent discussing threats and not enough time spent on discussing the mitigations. How many, a show of hands again, is how many people have you gotten into like arguments in a room? You may be tired, it may be windowless like this, the air conditioner's failed, okay? You don't have any water, you're annoyed, and these people are arguing with you about like the threat that'll happen if a blue elephant falls through the roof. And you're going, what? And you argue with the person, they say like, no, we want to know that threat, we want to know what that's, and you never get to the mitigation. That's the good part of the story. That's what you want to get to, is the mitigations. So problem number one. Problem number two, data flow diagrams. I used to love them, now I don't love them so much, okay? They look like this, they can look a lot worse. You've got trust boundaries, you kind of slice between things, and you kind of say like, well, okay, I've got 4 or 5 different trust boundaries coming over the place, but I don't know what is a higher level of trust and other things, and I get things screwed up, and I don't know, it starts becoming really messy. And then I deal with the request response on the flows. Okay, all right, here's a question for you guys. What's more important to you, a request or a response? What's more dangerous to you? Show of hands, request. Show of hands, response. Why do you think response is? Response is actually, I would make an argument that request is more dangerous of the two. Because if I'm an attacker and I attack the request, I'm attacking the command. I can get any response I want. If I'm an attacker, I can always get the response. But if I want to slow down or if I want to mitigate an attack, I go and I mitigate that request. I protect that request right there as opposed to response. And by doing that, I probably will protect the response too, because I'll create a single channel right there, like TLS, for example. Okay. Who else seen something like this? This is where it gets really interesting. Do you think that thing reflects what the underlying architecture is? Probably not. Probably some guy has been stressed out, did that, went, yeah, check it out right there. It's my data flow diagram. And the architect looked at him and goes like, what the hell is that? And the problem is, now you've got the DFD not looking like the architecture, and they get out of sync. And you get out of time. And you don't go back and visit this thing until 2-3 months later. They've gone through a number of sprints. They have an architecture that doesn't look anything like this. Basically, your threat model's so out of whack right now, it's useless. And you've got to start over again. We don't want to get to that point, okay? Oh, and this right here. You need one of us involved. Okay, you can jump it onto the security champions if you have any. Okay, they might understand some of this stuff, but you end up getting involved every time, and you end up having to get a lot of hands, and you end up doing this, running out of time. So how many people have continuously run out of time when doing threat models? Show of hands again. Yeah. We love it. We all love it. That's why you're sitting here right here, and you're listening to me babble on about this. We love doing threat modeling. The problem is we have that issue with time, okay? And then you come to this. You come to the final sprint. You're out of time. Your threat model is out of whack. It's kind of useless. And you just screwed up, okay? And you've allowed flaws to get into the system, which you don't want to do. One of the problems, actually, before I go further, is because we focus on this. As a group, we say, like, we got to make that threat model complete. Doesn't that idea go back to old waterfall methods? Waterfall used to be all about doing designs to the nth degree where you get everything complete. How many people work for a large company here? Or have worked for a large company? Almost everybody, right? And the whole thing about the large companies used to be, and still is they get these security requirements, they get these requirements, and they do the nth degree of their requirements. And then they require more requirements, and requirements for requirements, et cetera, et cetera, et cetera, until it's so complete that they've missed the boat anyways, and the product's already shipped. We don't want to get that way with threat modeling, okay? Threat modeling is supposed to be a way of getting there. It's supposed to tell a story. So how are we going to do that? We're going to use agile architecture. First point right here. Are you guys familiar with this? For show of hands. Some people are. Okay. This is actually, I know it's kind of vague and everything, but it's actually very powerful because you can talk to business with this. On the left-hand side, you can say to the business, you guys are responsible for this. On the right-hand side, you can talk to your architects and you say, you're responsible for this. You're a strategic architecture, right? You're responsible for consistency. You're responsible for providing patterns to us. When you provide the patterns and frameworks, we can then work with them to create secure patterns and secure frameworks. Then you have the second part of agile architecture, which is called emergent design. It's a more organic approach right here. Now, I've circled model storming because that's kind of the most important part of it. But you can look at every one of these things. You can say threat modeling should touch on every one of these issues right here. Stakeholder participation, correct? Okay, what about prioritized requirements, prioritized security requirements? Yeah? What about multiple models if you wanted to simulate different things? You want to be able to do multiple models, don't you? The problem is we don't get enough time to. You want the threat model and the underlying to be a single source of information, et cetera, et cetera, et cetera. These things all tie together. So we bring in, I'm just going to talk briefly about OpenSAM right here because I did a very interesting talk with a bunch of executives a couple weeks ago. And they brought me in to basically scare the hell out of them on security. And I did that. I threw FUD at them. I told them I was going to throw FUD at them. But in addition, I also gave them a very powerful tool. I said, I want you guys, the first morning, I'm going to talk to you guys about FUD, and I'm going to scare the hell out of you. And then in the afternoon, I want you guys to take all of your business objectives, and I want you to map them to these business functions in OpenSAM. And I gave a brief description of the 12 functions underneath, the 12 categories. So they spent the afternoon, and I said, look, you're allowed 3 different ways of categorizing this. A value of 3 is it's got major effect. A value of 2 has got, minor effect, and then a value of 1, it's got minimal effect on this. And once I gave them the definition of all what these different 12 items were, they went through each one of their 10 business objectives, and they mapped that to that. Why is that powerful? Well, Tash knows, because if you can start speaking business by using security, you can then tell them what a flaw in a threat model will mean to their business objectives, won't you? It's easy, you just mapped it out. You can say, look, threat assessment, that's going to, it's going to nuke your bottom line of profitability. You've already done the work, you know that. Because if you have them do the work, then they can follow through. That's my main thing about OpenSAM. I love it. That's where you can use that. Okay? Rapid prototyping. So here's another thing we bring in. So we got agile architecture, we got now rapid prototyping, which is software prototyping, right? And it's very useful because you have to understand there's 4 points right there. Get your basic requirements. So you generally do with a threat model, right? Write up a kind of a design, a conceptual design. Take that conceptual design, test it. Threat modeling again, right? Poke holes in it. And then revise based upon your results. Do that 3 or 4 times, and you've got your threat model, and you've got your results of your threat model, and you can put it in before you get any code done. Do it during the sprints, and you can improve upon the code as you're building it, right? Rapid threat model prototyping is all about 3 things. A consistent framework. We're going to do this again and again and again across all sorts of different things. Repeatable process. I can repeat it, I can do it like that, which means eventually I can do what I can automate it. Because then I don't have to, I don't have that much time. If I can automate it, that means I can spend more time doing other things and not writing up reports. Here's a question. Who all here likes writing reports? Yeah, I thought so. I was waiting for one person to raise their hand, but no, okay. And then the last part here is measurable data. Because the problem that we have is if we don't have measurable data, how can we measure how efficient our threat models become or how efficient our designs become over the course of a number of sprints, right? So it's perfect for DevOps. Second part's right here. A threat model should start the conversation, not finish it. So we follow by the second part here. You guys are familiar with the 80-20 rule, right? Pareto principle. 20% of the effort, get you 80% of the way. And then you iterate the rest of the way. In 2013, to give you an example, Wired Magazine had 3 security professionals crack into a hashed password database. And the first guy was given, one guy was given a day, then 2 days, and 3 days. So the guy who did it in 1 day, he cracked 60 or 75% of all the passwords right there using the common methods. The second guy incrementally increased it to 85%. The third guy did 90%. Okay, so it shows you that you get the most bang for the buck in the initial iteration. Same thing with this right here. So don't make your threat model comprehensive. I'm telling you right now, let it be kind of loose, let it be a framework, and iterate over it. This is where we come down into the DevOps steps. So I'm going to walk through the next thing right here is I'm going to go through the various DevOps steps. So I'm going to map the threat modeling and the rapid prototyping as I see it. And I would say stop me, but I know we're running slow on time, so I'm not going to allow you to stop. I'm just going to keep on cranking away on this. You can ask me questions afterwards. So let's start off with the first one right here, planning. During the planning part right here is where you get together and you do model storming, usually sprint 0. Okay, you're about to kick off your production, so you sit down sprint 0, you do some model storming, you talk with the architects, you get your initial diagram out there, right? Okay, So what do we do next? We use stride. Except for, I don't like the definition of repudiation. Try explaining that to people who've never heard of security beforehand. Because then they go like, well, is spoofing the opposite of non-spoofing? And then I get these arguments with these people. So I got into a big discussion with a number of my peers. And I said, actually, think about this. Repudiation in actuality is a lack of authentication or lack of integrity of data. Either the data doesn't exist, or it's poor. Okay, you can attack for example, you can nuke a log file or something like that. And if you don't have good authentication, well, hell, I can charge in there and I can repudiate. I wasn't there. It wasn't me. It was Tash. So that by doing that, then I was able to explain this, and I was able to use, oh, hang on, I'm going to go back again. But if you take a look right here, the interesting thing is you start seeing all sorts of different designs like that. Repudiation, combination of the other two up above there, kind of fits in well. As you know, CIA fits in this too. So not the guys over in Langley, but, so you can explain a lot of different things using stride. It's a very powerful tool. Okay, so the second part right here, during the model storming right here, is that we then take the threat model, and we save the threat model data in the diagrams, okay? Or you attach it to a diagram using a spreadsheet or something like that. You associate it with the underlying architecture. You don't create a data flow diagram. Use a process diagram or context diagram. Big break right away. Now you guys may shake your heads and go like, well, we don't agree with that. Fine, use the data flow diagram if you wish. I'm just trying to save you time, okay? So you get something like this. Now this is an actual project. And the project you see on the left-hand side right here is you see a website which calls into an API gateway. Same with third-party apps called directly into the API gateway. And you have a number of microservices sitting in between. You have an uploader service and a downloader service. The uploader service will upload data, whatever it is, dump it into blob storage, and it'll send a message to the queue. The queue will then inform parsing, data processing, and analytics based upon what the third party or the website say, and they'll do some stuff. Okay, the analytics part right there, the microprocess, we'll call it analysis rules, and then we'll fire that off, and then they'll all send results to the results data, which then the website or the third party can pick up using the downloader. Okay, everyone understand that? It's pretty simple, pretty straightforward, but there are a lot of things that are kind of similar to this. Okay, so the biggest thing here is the middle part, command and control, what we call elevation of privilege. How many, like if you look at stride and you say of the 6 elements of stride, what is the most dangerous element of stride? Is it spoofing? Anyone? Raise show of hands. Is it tampering? Is it repudiation? Information disclosure? Denial of service? Elevation of privilege. That's the most important one. That's why they made a card game about it. Because with elevation of privilege, I can get anything else there. I've got lateral movement in an attack kill chain with elevation of privilege. So what should be our primary objective in a threat model? To identify elevation of privilege issues. That's our first objective. So if you don't have enough time, you do your elevation of privilege issues first, and you can walk away and you can say, I've got my 80-20 rule built in. So let's roll with it. Now, during sprint 0, you want to find your elevation of privilege issues quickly, and that way you can find, you can put in numbers instead of dashed lines for your trust boundaries. All right? So an example, they're going to give you a bit of guidance here, and this is based upon doing this a number of times, a lot of times actually. So originally, I don't give any upper bounds on putting numbers on these things. If you want to put 50 as importance, go ahead, be my guest. But generally, a range of 0 to 9 works. That's the kind of first kind of recommendation I have. Now, the other thing too is that you want to be specific to the diagram itself. So anything that communicates to that diagram is considered to be outside of the bounds of that diagram, outside of the control of that diagram. That gives you your defense in depth. That's why I say right here, I say internal communication, external communication, I don't care. If it comes from outside to inside, then it's considered to be external. And then finally, that last point right there is you build in your defense in depth by looking at these things, by putting in numerical references instead of dashed lines. So for example, there's only one rule right here. If it's 0, it's out of your control. So you designate those 2 points right there as 0. They're out of your control. The next point right here is, it's the rule of thumb. If data hits the disk, it's going to be the highest point on your diagram. Now, I know that there are exceptions to this. For example, if you've got log files, and log files are kind of non-essential, okay, maybe it's not highest value. But if you've got something like this, like blob storage, or results data or analysis rules, they're going to be pretty high-value targets, aren't they? That's where the bad guy wants to go, right? Especially the analysis right there, the results data. That's why I gave the results data a 9. I said the blob storage may be an 8 because it's inbound information. Might be slightly less informational. And then the analysis rules, as an attacker, might be important for me, but maybe not as important as the other things right there. I could screw up people and anything like that, but I couldn't really get the results out of this, whatever it is. Now we've got our low points and our high points. Now another rule of thumb right here, guidance as it were, is that anything that is intended to interface with the external world or outside of your diagram, you designate as 1. Low trust, low value, whatever like that. So my website and my API gateway, both intending to communicate to outside interfaces, they're going to be a 1. Like I say, it's guidance though, because I have done a number of threat models where people end up with an API endpoint, which is a 6 or 7, and the team does this, and you say, oh, Jesus, guys, you've got a pretty important jump right here. You've got like an outside influence going into a pretty important API endpoint. You better secure that. What you're doing is you're allowing the team, when you do this, because you're not going to do it on your own, you're going to do it with the team. You're allowing the team to actually judge and to actually put these numbers in with your guidance and your help. That's a very powerful thing indeed. The team comes to the conclusion with your help. You don't give them the answers. And sometimes it may come up, you may come up with numbers. You may say, like, well, I don't totally agree with that. And you can discuss with the team. Fine, fair enough. But if the team comes up with the answers, generally, a size of 5 to 7 people is going to come up with pretty accurate estimates on what they think is critical or not. And then we fill up the rest of the stuff. So in this example right here, the uploader component, I gave it a 2, incrementally higher. And then I say the queuing, maybe a 5, maybe about middle of the road. It's pretty important, but it's not one of the highest, of importance because it's just sending messages. The parsing, data process, analysis components, maybe the analysis component might be a bit higher because it has actually its running rules, and maybe the other 2 are a bit lower because, well, they're just doing other stuff. I haven't defined. And then the downloader component, I'd say, is pretty important. So I rank that as a 6. Now, imagine if I'm doing it as part of a team, the team might come to the same conclusion. They might make the downloader component higher or lower. That's up to them. They know the software. I know security. I'm not going to tell them what their software is doing. That's a big thing right here. Make it a group activity. Yay. Okay, so we've gone on to the next section of DevOps right here, which is create. Now, what you've done right here is you set up a series of numbers on the diagram right here. You maybe put them into a diagram, you put them into a spreadsheet which is associated with the diagram. You've now linked the diagram with some threat data right here already. If the diagram changes and you don't add new data to it, then you know automatically you're out of whack, don't you? You don't have to go and look at another diagram. So we want to get to the good stuff. We don't want to get to threats and start arguing about threats. I told you this beforehand. We're going to shorthand the threats and we're going to longhand the mitigations. So this is where I kind of like come to a bunch of rules that I do. Okay. Funny enough, I've got 6 rules and there are 6 elements of Stride. The first one is elevation of privilege. So if you run out of time, if you do elevation of privilege issues first, you know that if you finish up that threat model, you don't do anything more, that you've covered like 67% of the territory. 5 minutes. Wow, okay. I'm going to speak fast. Okay, so first what we do is elevation of privilege issues. And the rule here is, it goes in a target element, and it's from low value to high value. So as you can see right here, going from the user to the website, from the third party to the API gateway, you have a ton of elevation of privilege issues, which we expect to see, don't we? The next part right here, spoofing threats. Spoofing threats are going to happen on the boundary elements. Again, on the target element, they're going to happen where it's less than 1, because you can have less than 0 and stuff like that, and where it's 1 or greater. So you have it on the website and the API gateway. Again, this is where we expect to see. We're looking for high probability areas right here. Tampering threats, there's all over the place, because we haven't defined anything yet, have we? We haven't defined TLS or anything like that. This is just an empty diagram for us. So tampering threats exist everywhere. Okay, and they exist from low value to high value on the flows. Okay. 4 minutes. Repudiation threats. So this is an interesting one. So repudiation threats exist where you have an issue with either tampering or spoofing. So you're going to see repudiation threats kind of clustering around this area right here. Now people may say to me, they may argue like, well, hang on, there might be repudiation threats throughout the thing. Yes, but these are your highest probability areas right here where you're going to repudiate. And you're going to find them right at the beginning. Okay. Next we have information disclosure threats. Now this is an interesting one. It goes from high value to low value on the flows. And the definition, again, the reasoning is that you've got more sensitive information potentially being passed to a less sensitive zone. You've already defined those zones right there. So the interesting thing I've found is, with tampering and information disclosure threats, you protect one, you generally protect both of them. Okay, like TLS, for example, will protect both of those. Denial of service threats exist on the flow or target element where it goes less than 1 to greater, so it's very similar to where the spoofing is. And again, the reason is if I'm an attacker and I get deep inside of this system, you're not going to be worried about denial of service, you're going to be worried about a lot of other things. So denial of service has the highest probability of happening where the attacker can influence it more directly, which is on the external components, or the components interface, or the flows interface. Now we've got all that right there. Boom. Okay, we got a whole set of threats, don't we? Now we find out we can use zone math because we've got the different numbers where we're going to concentrate our efforts. Sorry if I'm running through on this fast, folks. I think we're kind of trying to catch up, are we? So if I could speak faster, I would. Okay, so in that case right here, you look for jumps. Take a look right here. So your third party goes to your API gateway, then jumps to your downloader component, which then jumps to your results database. You see the differences right there? 0 to 1 to 6 to 9. That's going to be pretty dangerous, isn't it? So I'm going to probably spend a lot of my effort and time getting that right, locking it down, which again is logical, right? Because we don't want people to access that results data because that results data might be anything. It's personal information, it's sensitive information. So it marks up. But if you get a very complicated model, much more complicated than this, it'll find these things really fast. And here's the beautiful thing about it, is with this information right here, you can go back to people who are non-technical and you can say, I've done the work. It's not just intuition. It's not just like, security SME intuition. I've done the work and here you go. This shows you evidence why you should be doing this. So we write through the mitigations. Now, here's an interesting thing. So when people do mitigations, do you guys have your own mitigation patterns or anything like that? Or do you work off of OWASP patterns? What do you guys do? So a show of hands for OWASP patterns. A few people. Your own mitigation patterns. A few more people. No mitigation patterns. Everybody else. So, okay. No, what you want to do is you want to minimize the amount of effort you spend on doing the mitigations and everything like that. So by that doing right there, I recommend that you do the mapping that I told you beforehand with the OpenSAM, and from OpenSAM then you map down. And what I do with like a lot of my teams, I show them OWASP top 10. I say, okay, you've got the OWASP top 10 right now, and use that as kind of a framework. I know it's not a great one, but look, everyone understands it. And then from that, they can roll up to OpenSAM, and then the business guys can understand. And if you use that, you crowdsource all the mitigation patterns initially. You don't create your own, and then somebody doesn't have to maintain them, et cetera, et cetera. All right, so the mitigations, like I said, they should come from patterns and requirements you have, and this is where it ties back to agile architecture, because your guys who are doing the architecture, the security architects, and also the functional architects should be giving you patterns from the top. You should be feeding them back up there. Again, I apologize that I'm blazing through this thing right here, but I'm almost done. Yeah, I'm on time. No, I'm over time. Right, okay, time to wrap up. So, tampering flow mitigation, here's an example. Then you can, further on when you package it up, you can stop pull requests by using this information. You can send it out as JSON, XML, blah, blah, blah. Okay, you can do it, and I've done all this beforehand, folks. I apologize again. But you can attach the data to the builds, you can send the builds out there, so you can actually put it into a Jenkins. Other things too, such as you can do elk stacks, Splunk, dashboards. You can then start creating dashboards to pass this data back so people can start consuming it. Then you track the issues in a risk register if you want to, because now it's become data and you can pass that through. And we do model storming again, and thank you very much. If you want more information, either talk to me, pigeonhole me before I disappear, or do search for GitHub Rapid Threat Model Prototyping. I strongly encourage you to download that documentation, to yell at me, come back with some stuff if you find it very interesting, and updates. Thank you very much, folks.
Thank you, Geoffrey.